Vallecitos Boiling Water Reactor is operating under the first developmental power reactor license issued by the United States Atomic Energy Commission. It is part of the Vallecitos Atomic Laboratory near Pleasanton, California. This reactor was built by the General Electric Company primarily to obtain vital operational data for the 180,000 kilowatt Dresden nuclear power station near Chicago. The Vallecitos reactor, connected to the power system of the Pacific Gas and Electric Company, is furnishing Northern California with the United States' first completely privately financed, commercially generated atomic electric power. The reactor is housed in a vapor-tight steel enclosure 48 feet in diameter and 100 feet in total height. The enclosure is rated at an internal pressure of 45 pounds per square inch. It is accessible through two airlocks, which are part of a comprehensive safety system. Located below the 4-foot-thick operating floor of the reactor building and inside a 20-foot-high stainless steel-clad vessel, the reactor itself is a light water moderated and cooled boiling water type. The design provides for a high degree of flexibility. This makes experimental modification possible, and it permits investigation of such matters as operation cycles, nuclear stability, control systems, instrumentation, and heat transfer conditions, all for the purpose of improving plant efficiency. The reactor can operate with either natural or forced circulation of the coolant, using either direct or dual cycle. Fuel elements for the first load each contain about a half pound of fully enriched uranium oxide, fabricated into thin plates clad with stainless steel. Some of the elements contain 6 active plates, and some contain 9. The active core, which contains about 23 kilograms of U-235, is approximately 3 feet in diameter and 3 feet high. The initial core contains 101 elements securely locked in place by an upper grid. Prior to startup, the many valves in the power system are remotely positioned. The moderator coolant is demineralized water. Reactivity is controlled by 7 boron stainless steel control rods. The central rod is 6 inches wide. The remaining rods are 12 inches wide and 3.5 feet long. Next, the 20-ton pressure vessel head is installed. The 80-ton steel upper shield, which serves as both biological shield and mounting for the control rod drives, is rolled into place, and the reactor is ready for power operation. The date is October 24, 1957, less than 17 months after ground was broken to begin construction. Operation of both the reactor and the turbine generator are controlled from a single 5-section panel. The first control rod is selected and withdrawn. Neutron counters indicate the resultant low level of neutron intensity. Control rod withdrawal continues, and instruments such as the log power meter indicate and record reactor power level as it increases and causes the water to boil. A closed-circuit television system is used to monitor the operation of equipment within the reactor enclosure. The reactor continues to warm up and to increase its pressure, and in less than 4 hours from the cold condition, the pressure is up to 1,000 pounds per square inch. The television camera provides the operator with readings of the remotely mounted instruments to assure that the reactor is ready for power operation. The operator admits steam to the turbine and increases turbine speed to 3,600 revolutions per minute. The operator then synchronizes the turbine generator. Closes the main circuit breaker, and the power plant is on the line. Power level is increased to the rating of the turbine, 5,300 kilowatts. An important operating characteristic, the stability of the Vallecitos reactor, has been demonstrated over a wide range of conditions. Since the time of startup, the reactor has been operated over a range of pressures and at thermal outputs up to 30,000 kilowatts with absolutely no signs of instability. and experience indicates the reactor is operating well below the power level at which instability might occur. The reactor responds smoothly to changes in turbine output. An almost instantaneous change of 25% of full load can be made with a reactor pressure variation of about 10 pounds. The turbine load can be increased from 0 to full load in as short a time as 20 seconds with no severe drop in reactor pressure. Radioactivity of the turbine generator plant has been found by test to be exceedingly low, 4 to 6 milliroentgens per hour. After 900 hours of plant operation, the turbine was opened and direct contact maintenance was completely practical. The reactor was licensed initially for a thermal output of 20,000 kilowatts. In January of 1958, the licensed output was increased to 30,000 kilowatts. Reactor performance thus far has exceeded expectations. It is believed that with minor modifications, operation to power levels considerably above 30,000 kilowatts will be possible. Plans have been made to apply for licenses to operate at higher powers. The Vallecitos Boiling Water Reactor provides additional operating proof that the boiling water reactor is a safe, stable, and potentially economical nuclear power producer.